Okay, after exponential equations come log equations. Just like with the exponentials, there are two different types. And on the screen you see here, I show you the two different types. So on the left side, you have the log base 4 of x plus 8 equals the log base 4 of 21. And on the right side, you have the log base 3 of x minus 5 equals 2. The difference is the one on the left has a log on each side. Every term has a log. So if every term has a log, you're going to set the pieces equal. Okay, now look at this one on the right side. What you notice about this one is every term does not have a log. Okay, so if every term does not have a log, you have to make a circle. It's actually pretty easy. Let's try a few. Okay, so here are the original problems that you see. The first thing I want you to notice on this log base 4 of x plus 8 equals log base 4 of 21 is that they both have a log. So if they both have a log, you're going to set the pieces equal. And you'll say, well, what pieces? Okay, so on the left you have log base 4 of an expression, and on the right you have log base 4 of expression. Well, the log base 4s are the same. You just have to set this box equal to this box. So in other words, x plus 8 has to equal 21. That's how you set your pieces equal. What's ever behind the log on the left, what's ever behind the same log on the right, just set those two pieces equal. So to solve this out, I just subtract 8 from both sides, and x equals 13, and that's your answer. Now you'll notice that the directions say check. Now you're not necessarily checking for correctness, although that does work. What you're checking for is to make sure you don't take the log of a negative number. So let me go to the side over here for just a minute. See how you have the log base 4 of x plus 8? The x in this case was 13. So if I put a 13 right here, I would get the log base 4 of 21. I need to make sure that this number inside is positive. Okay, if it's positive, it's a good answer. So when I plug 13 in there, I do get a positive answer, so it's a good answer, and that one works. Okay, I'll check some more as we go along, and that should help you a little bit with that. Alright, let's get ready to do the second one. What you notice about this second one, log base 3 of x minus 5 equals 2, is they do not have logs on each side. So since they do not have a log on each side, you're going to make circles. You'll say, what do you mean by make circles? Remember earlier in this chapter, we started with our base, we circled around, and we came back. Now always start with a base. Just remember that. So you have 3 to the exponent 2 equals x minus 5. That's what I mean by make circles. 3 to the second is 9. When I solve out this equation for x, I want x by itself, so I'm going to add 5 to both sides. So 14 would equal x. That's your answer. Now let's talk about checking with this one. If you look at the log expression, you have to make sure that what's ever behind the log is positive. Okay, so right now behind the log I have an x minus 5. Well, my x value is 14. 14 minus 5 would give me a 9 right here, and 9 is positive, so that means that this particular one works. You'll say, now what do you mean by positive? Well, let's pretend for a second, just to pretend. Let's pretend we got an answer like 4. Pretend. If you plugged in 4, you would get the log base 3 of 4 minus 5. That would give you the log base 3 of negative 1. Well, you can't take the log of a negative number, so you would have to throw it out. So that's what you're looking for. You're making sure that if you took this value here of 14 and you plugged it back in, 14 minus 5 is 9. That's positive, that's good, and that's what you're checking. Okay, so we have 2 more of these to do before we step out and get the bad ones. Alright, in this first one I see log equals log. Great. All you have to do is set your representative pieces equal. 3x minus 11 equals 7. Okay, I'm going to add 11 to both sides. So 3x equals 18. Divide by 3. And x equals 6. If I plug 6 back in to check, 3 times 6 minus 11 would be 18 minus 11, that's 7. 7's positive, so that means this is a good answer. Alright, so let's look at our second one. What I notice about the second one is it does not have logs on both sides. So since it does not have logs on both sides, you're going to make your circles. Always start at the base. 4 to the 2 equals 3x plus 10. Well, 4 to the 2 is 16. So we solve this out. I'm going to subtract 10 from both sides. 6 equals 3x. I'll divide both sides by 3, and 2 would equal x. Okay, let's plug that in to check really fast. 3 times 2 plus 10. Okay, so that's 6. 6 plus 10 is 16. 16 is positive, so that means this is a good answer.